This e-content explains the phosphorus cycle. Phosphorus is one of the most important elements on Earth. It controls many of the biogeochemical processes in the biosphere. Phosphorus is the 10th most abundant element on the Earth. Approximately 300 naturally occurring minerals in which is required for our structure. The phosphorus cycle is slow. The importance of this mineral is perhaps best demonstrated by the diversity of its sources. Assuming that nearly all the phosphorus present is in the form of apatite, igneous rocks contain between 0.02 and 0.1%. Many of the most fundamental biochemical records for life contain phosphorus, generally linked to long, complicated organic molecule 5-phosphate ester bonds. Among the impressive list of compounds in which phosphate is a necessary constituent of the nucleic acid, DNA and RNA. In these compounds, phosphates covalently link the mononucleate units form long polymers which, depending on the composition of the attached base, encode all necessary genetic information. Phosphate also plays a central role in the transmission and control of chemical energy within the cells, primarily via the hydrolysis of the terminal phosphate ester bond of the adenosine triphosphate molecule. Phosphate containing compounds are abundant in all organisms. P is one of the major components of all organisms. The dominant process controlling the movement of phosphate through a terrestrial ecosystem are systematically presented. In general way, the overall movement of P on the continents may be envisioned as the constant erosion of phosphate from continental rocks and transport in both dissolved and particular form by reverse to the ocean, chopping occasionally along this pathway to interact with biological and mineralogical systems. The majority of the eroded from rocks remain trapped in the mineral lattices of the particulate matter. It will be transported with the suspended material or bed load downstream until it evenly reaches the estuaries and the ocean, never having entered the biological cycles. A small proportion of this is leached from the minerals into the solution. However, it is readily available to enter biological cycles and to reach with the inorganic soil particles. Human impact of phosphorus. A number of human activities, use of fertilizers, artificial eutrophication, has a great impact on the phosphorus cycle. In general, NPK, nitrogen, potassium, phosphorus, which are major component of chemical fertilizers. These phosphorus fertilizers increase the level of phosphorus in the soil. Overuse of these fertilizers reduce the fertility of the soil, and this is also harmful to the microorganisms present in the soil. When these are washed, causes eutrophication. This leads to the growth of algae. These form algal blooms or dye, which is toxic to the aquatic ecosystem. This is the phosphorus cycle.